Hey everybody, we are going to look at graphing velocity today. So a little bit of a recap. We've been using position versus time graphs to analyze the motion of objects. We can find speed from a position versus time graph. So we're going to look at segment C. And in this case, the object went from a position of positive 3 meters to a position of 0 meters. Now, we don't care about the direction of motion because we're dealing with speed. Speed is a scalar value, so all we care about is how far that is. What's the distance traveled? How far did someone's shoes have to walk? So that distance is going to be 3 meters. And so now we know how far we went. That took a period of 1 second. And so to calculate our speed, we just put 3 meters over 1 second to get 3 meters per second. Velocity is a little bit different in that we also include direction. So we're still going to look at segment C. Same motion. The object is moving from a position of positive 3 to a position of 0, the origin. And we do care about direction this time. So that is a displacement of negative 3 meters or 3 meters backwards. And that took, again, a period of 1 second to make that motion. And so when we put our negative 3 meters over 1 second, we get a velocity of negative 3 meters per second or 3 meters per second backwards. Well, let's do that again, except let's do it for the entire trip. So for our starting position, we are starting at the origin here. And our ending position, we are actually finishing at a positive 1 position or 1 meter in front of the origin. Okay, so those are starting and ending points. And so our displacement for the entire trip is 1 meter, positive 1 meter or 1 meter in front of the origin. And that took 19 seconds. So the entire time interval from time equals 0 to time equals 19 is a change of 19 seconds. And so 1 meter over 19 seconds gives us a velocity of 0.05 meters per second forward. Now, what if we graphed velocity as well? We've only been graphing position and finding velocity by looking at the steepness or the slope of the line of the graph. But what if we were to actually graph velocity by itself? So we're going to do that here. We're going to analyze motion, some motions of an object, and we're going to graph both the position of the object and the velocity of the object over time. All right, so our first motion is going to be the object moving from the origin to a position of positive 5 meters or 5 meters in front of the origin, and that's going to take 5 seconds. So on our position versus time graph, that's going to look like this. We see a change in position from the origin to a position of 5 meters in front of the origin, and that took 5 seconds to do that. So our velocity is a positive 1 meter per second. So on our velocity versus time graph, that's going to look like a flat line at the 1 meter per second y value, and that is going to be over the course of 5 seconds. That's telling us this object had this velocity for 5 seconds. So very, very different so far. Our next motion is the object is going to stop moving for 2 seconds, so I guess I should say not motion. So that's a velocity of 0 meters per second, and we know that on a position versus time graph, that is a flat line. Now on the velocity versus time graph, that is going to be in a very different location. And it is going to be here on the x-axis. Now we have to be careful because we are so used to looking at position versus time graphs that when we see a line or a point along the x-axis, we say, oh, it's at the origin. But velocity versus time graphs provide no information on where the object is. You cannot tell where the object is based on a velocity versus time graph. You can only tell how fast it is going and in what direction, as well as the change in velocity, which we'll get to later. Our next motion is the object moving from positive 5 meters to the origin in 1 second. So it's still at a position of positive 5 meters or 5 meters in front of the origin. It's now going to move back to the origin, and it's going to do that rather quickly in 1 second. So velocity here is negative 5 meters per second. And on our velocity versus time graph, that means we have to put the velocity line down here at negative 5 over the course of 1 second, from 7 to 8 seconds. Our next motion is the object moving from the origin to 2 meters. Sorry, negative 2 meters. That negative got cut off here. So the object is moving from the origin to a position of negative 2 meters, and it will do that in 2 seconds. And so we have a velocity of negative 1 meters per second, and that is going to look like this on the velocity versus time graph. So negative 1 meters per second velocity, and that is happening for these 2 seconds here. Finally, the object moves from negative 2 to positive 4 meters in 4 seconds. And so that is a change in position, a displacement of positive 6 meters over the course of 4 seconds. And so that gives us a velocity of positive 1.5 meters per second, which is going to look like this on the graph. Now, I do want to point out that this graph, this velocity versus time graph, looks a little weird. It kind of looks like a Tetris game. And that is because this is describing changes to velocity happening instantly. Now, that would be like you traveling in your car, and as soon as you hit the brakes, you go from, say, 60 miles an hour to 0 miles per hour instantly. That would be very bad for you. And that's not how objects typically move. There is typically a change in velocity, which we refer to as acceleration. And we're going to cover that more later. All right, so let's summarize what information we can get from these two types of graphs. In terms of the where, the location, the position of the object, we can get that from a position versus time graph, but we cannot get any position data from a velocity versus time graph. It does not tell us anything about where the object is located, only about how the object is moving. We can get the direction of motion from a position versus time graph and a velocity versus time graph. We can also get the rate of change in position, or the object's velocity, from a position versus time graph and a velocity versus time graph. But the rate of change in velocity, or what we refer to as acceleration, we cannot get that from position versus time graphs, at least not very easily, but we can get that from velocity versus time graphs. So that's an extra piece of information that we can get from velocity versus time graphs. The acceleration, or the change, the rate of change in velocity of the object. And we'll talk more about that in a future video when we get into acceleration.